Okay, Steve, I'm going to do a quick one today. This is something that I've been asked for a very long time, which is people ask me all the time, they see how a Hugo arms work, they see how a Versus arm work, they see how an Intuitive's arm work, but they get a little bit struggling on how could the Ottava arms work from under the bed. Well, I don't have any definitive information, but what I have got is I've got a very interesting set of patterns that they did that shows potentially how it can work. This doesn't mean, I want to really make sure this is clear. This doesn't mean this is exactly how it is going to work. But as they've just updated this pattern very recently, I suspect that it's somehow sort of how it works. And the pattern's quite cool to show you that, with some really nice features actually. And if they do it this way, it should be quite interesting. So I'm going to take you through this, and forgive me, I'm going to go into document view, and I'm going to try and show you what I've got here. So working through this presentation, what I'm going to do is going to go here. Okay, and hopefully I'll be able to go to the next slide. Okay, good. Right, so on the presentation, how might the arms work for Ottava? So this is a picture that I've had for a while, and it was actually Tom Salemi who nabbed this at SRS some time ago, about a year or so ago at SRS. And from what I can understand is I don't think they wanted this picture actually on at SRS, but it's there and it's nice. And I think if I was them, I'd be showing this all the time. But hey, that's me. And what it shows here for those to orientate is that this is a bed. This is where the legs go. Down here, this is where the body goes, this is where the head goes, and underneath it is a square section, and coming off that are four arms. Oh, you have to excuse me today, I've got a very dry throat. So coming off this are four arms, and you'll see in a later that these are coming off at 45 degrees here, and there's a reason for that, which I'll show you in a bit. So these four arms come from under the bed. Instead of coming as a boom from above, they come from under the bed, and that adds a degree of difficulty, and it makes it difficult to do, but it brings some advantages as well. So let me run you through how I think it's going to work based off their designs. So again, maybe a clearer view here. So this is the piece that's attached to the bed, and as the arm gets skinnier as you go through the joints, you head towards the end of the arm, which is where the payload is, or where the Z rail is going to be. And the original Auris design was like a round circular system where the Z axis of the instrument ran through the center of the donut. This instead is much more of a standard Z rail design, which is a bit like an intuitive arm design. And you basically have a trocar that clicks onto the bottom, or a piece that clicks onto the bottom of the trocar. Go and look at any intuitive image, and then a rail that goes up and down. And I'll show you some pictures of the arm from the patterns, which I gather is what they've reduced to practice. So here's a side view of the bed. So that's looking at the bed sideways on. There's a pillar under here, and then there's a support mechanism that comes out and then has the arm that then goes to the payload of the arm. This is an old Verb pattern, but I believe that this is probably how it's going to work, or probably will work. So you end up with the arm coming from under the bed, up and over the bed, and delivering a payload arm there. And I've got some different pictures of this as well. So here's probably the best picture that I can find of a render of the old Verb arm, and I strongly believe that this is what they're going to end up with, is something very similar. So to orientate you again, the bed would be down here. This is what goes underneath the bed and connects onto the central pillar of the bed. And this arm brings out to what will be a standard robotic arm. And then you have a shoulder, you have an elbow, and you have a joint up here. And then what this joint does is it has almost like a second robotic arm that sits on this, which is the payload arm. And from this, you have here the Z rail. And this is the instrument drive pack. This is the instrument. This is the trocar. And this rides up and down. Maybe I've got a better picture. There we go. So again, all from their patents. So it's all public. I don't have anything secretive here. And I can't guarantee that this is exactly how it will work, but it would make sense if it did work this way. So if you look at the instrument drive pack, they would have potentially up to 6 drives here. And it would be for pitch, yaw, rotation, and Stapling would also be on there as well, so that you could drive a stapler back and forwards. And the reason that they've got 6 is so that you can have very advanced instruments on here. But again, this arm comes out from under the bed, up over the bed and down, and points down, and then you would have the port here sitting right into the patient, and this whole thing would be moving around like this. So these are the main arms that bring the payload towards and above the patient, and then this is the arm that is going to move around and do a lot of the dancing. And this is a fairly short Z rail here, which is nice, compact, and it's not got a lot hanging off the back, which is very, very nice, which you can do when you're coming from the bottom down rather than coming from the top down. So one of the nice designs of coming out from under the bed, you can have a very, very short and compact Z rail, which you're going to need to stop clashes of instruments. Okay, let me go here. Oh, let me go to this view here a second. Navigate and make sure I go to the right picture next. Okay, come off there. So for the engineers who are looking at this, this is their basically... What they have is they have the different degrees of freedom so that the arm can rotate in different ways, so that it can swing out from under the bed. This is the bed. This is where it swings out from. So you have one joint that swings it out this way, rotates it in this plane. And then you have a different set of joints that all rotate in different ways, so that you can make sure that when you want the tip of the instrument to move and you move your hand controllers, the arm's got enough degrees of freedom to get you exactly where you want to go. Very, very complex, and I would imagine that looking at this, the amount of motors and controllers that you need in there, the one thing I would say about this is going to be an incredibly expensive arm to make, I would imagine, but I can be proven wrong on that. But I would think it's going to be fairly complex to make, and therefore probably quite expensive to make. So I'm going to put an estimate onto this of... You would probably need to be selling this entire table and making a profit in the early days at about, so if you look at the table, all the mechanisms, the 4 arms, the tower, the controller, probably about $1.8 to $2 million would be an ASP on this that you would need to do to make that sort of thing work, just as a guess. Right, now let's get into the setup and everything. So this is a very interesting pattern that shows some of their screens, what they called, and I think it was from the Verb days, stadium view, which is allowing you to see as if you were seeing everything. And I've always asked the question, how would you bring the patient and drape it? Would you drape first, bring the patient in? Well, this says a different way. And this looks like an interactive screen that you would have on your tower, and you'd be able to select your apps from Polyphonic. You'd have an endoscope view. You'd have some how-to guides, case information. Here's a gastric bypass in this one. This looks like it's an arm, but I'll come back to it in a minute. And you'd have your information, which looks very much like Dualto. And this is interesting that there'd be a battery indicator here, which means that this thing's probably got a serious amount of battery backup, which I think is going to be important. Because you're going to want to be able to move this thing or stop it drooping or things like that. So here's position patient 1. So this is what this pattern says. And again, I want to stress, I can't confirm that this is how they will actually do it in a case, but this is what the pattern shows. And they've just updated this a couple of weeks ago. You wouldn't do that unless you're really trying to reduce it to practice. So bring the patient in and they'd be positioned on the bed. So there's the legs. So you remember that picture we had before where we had the 2 legs with the split in the middle looking down and the forearms from underneath, which is there. That's the 2 leg things there, and that's the arm. So it looks like they did go with that design. And then what you've got is you've got the forearms underneath. So you would first of all position the patient. Then what would you do? So the next thing you're going to do is go to a deploy and drape arms. So my question was, do you drape the arms first and bring the patient in, or do you put the patient and drape the arms? So in this, it looks like in this reduction to practice, what you would do is you would bring the patient in and then you would drape the arms around the patient. So you'd have the forearms and you'd drape the forearms. And it says here, use the table remote control to move the arms to drape position. So that's either going to be from the tower or they might have a remote control. And you're going to get those into a drape position. And what's going to happen is the arms are going to come out from under the table. All those joints that I showed before are going to roll up, come up, and they're going to now position themselves up like this. And that's ready to drape. And that's going to be in a position where they're out at 45 degrees. They're up like this, and the nursing team can just come and drape over the arms quite easily without touching the patient and having the maximal space between each arm. Then what would happen? You go into the arm, what they call prepare the arms, use the table control to move the arms to a prep position. Now, I couldn't understand whether this was preparing the arms ready for the surgery or preparing the patient. So you prep the patient at this point, you drape the patient, prep the patient at this point. The only thing I would say here is that anesthesia-wise in many countries, that's going to be a challenge. So I'd love to know make sure that in some countries that they've dealt with that, working up there like that. We'll talk with the anesthesiologists and anaesthetists in many countries, but I'm sure they've worked that out. But you've got a position where what you're able to do is move all the arms to one end of the table, so you've got full access to the patient down here. Probably drape them, drape the body, prep the body, put the drapes on. Now, next is place ports. Now, this is interesting. Don't know whether they'll have really done this, but this is recommended port position. So it gives a view on the screen and sort of tells you where you should put your ports for the best placement. Interesting figures from this. You've got an 8mm robotic port. So it is telling us, maybe confirming here, that we've got 8mm ports going to be used with the Ottava system, which would make sense to me. And I don't see why they wouldn't do that. They are the standards today. Very linear port positions though, and again, this is the problem of having a fixed boom, whether your boom is above the patient or below the patient. Not 100%, but you force the user to put the ports which is optimal for the robot, rather than putting the robot where it's optimal for the ports, which you get with modular systems like Versius or with Hugo or SSI. Slight differences, but that's the pros and cons of what you get. Right, and then you're going to dock the arms. So this is the point where what you'll do is the team around the bed will literally take, they've got the port positions, and then they'll move the arms and they will click them onto the ports. So that's the standard docking that you do with a Da Vinci from above, but this one does it from coming up from below, and you will dock the 4 ports on. So that means that the Ottava arm would be locked to the port, just as you would with many, many robots that are out there. Then you go on to insert the instruments, and this is where you'd say put on arm number 1 the endoscope, you'd put the grasper on number 2, you'd put a Maryland bipolar on number 4, and you put a scissors on number 3. And that would be the staff, the bedside staff will put them on, and you would insert the camera first, quite rightly, for safety or laparoscopic things. Interestingly, then remaining instruments. Table should be in 10% reverse Trendelenburg. I'm not sure what that is for teleop, but there we go. For some reason, they want to put in there. Maybe that's just for this gastric bypass. And you can see here, quite interestingly, that looks like potentially could be a stapler, but I'll come to that in a minute. So you've put the instruments on the arms, you've put them into the patient, the surgeon is sat at the console, and the next thing you do is you assign the arms. So you'll have a left control and a right control, and you see that the scissors will be put into the left controller. The endoscope is on arm number 1. The grasper is on arm number 2, will be assigned to the right controller. And if you want to swap that out with the Maryland, you might use the right to swap it between. What you'll see here on this image is one of the fears that I have of these systems is just how the airspace above the patient could become quite crowded. Again, this is just a pattern design. I can't say it's correct. I can't say what it's going to be. I can't say it's going to be exactly like this. But just theoretically, depending how thick those arms are, and you're trying to do a tight procedure, this is where you have a risk of clash. And I will bring up some patents about clash avoidance from all the systems, not just Ottava, in the future. But you've assigned the arms, and now you're ready to rock and roll. And it's interesting, you have this thing called stadium view. So one of the things that I've been talking about is their tower, and you can go and see my towers and hubs. And if you go to the towers and hubs post, the tower that's on there is taken from the J&J patent of their tower and rendered into a real image. That's what I did on that, because it looks like it's going to be a nice tower, and I'm pretty hot on the Dualto the whole way that they're going to do it. Again, So you want to always look in these, when you're looking at these patterns, there's a few things. So you've got different views that you'll be able to look around the room, because I think there'll be cameras mounted on the tower and you'll be able to look at different views. There'll be different cameras mounted around the room so that you can look at different views. They'll at least have an operating room camera view. And part of that is going to be about working on operating room efficiency in the future. And I still think there's a camera in the Da Vinci one that's not been turned on yet, but not 100% sure on that one. But interesting things, you've got XL needle driver and maybe a suture cut already in there. So there might be some instruments that we're all very familiar with. This is just another view of that to show the complexity and the level of complexity. And the reason I wanted to show this view on here was that, that looks like it's in the prep view, which I showed before. There's a lot going on underneath the table to make this happen. And I just wonder, about the manufacturing, the cost of this, the complexity of it and servicing of it, and just how much fluid is going to be dropping down into those arms. I've done a lot of cases, and if you end up with fluid dropping down into these joints, they are all draped, but you start getting gravity helping to get fluid pushing it down into the joints. And I do just wonder about this. And again, looking at how much room this is going to take around the table, how much real estate. Your pro is that everything's on a single footprint. The downside is that footprint is big. So you've got one footprint, but it's a big footprint. And the operating room staff have got to get around this. Again, I don't want to be picky here because I've not seen it used. I've not seen it in real use. And so it's hard for me to say. And I don't know if it's much worse than some of the other robots that are out there, the modular systems, but it's definitely not as good as what you get from coming above down with a boom. And this is really just an inverted boom if you look at it that way. There you take away all the gubbings so that you can see, take away all the see-through. So that's what it'll sort of look like. So it looks a lot less busy, and there's some room around there for the patient, for the staff, the bedside staff to get around. So maybe it's not going to clash. And again, when you put these back into their 45-degree positions. Did I have anything else in here? Yeah, it's just an older pattern, again, that I dug up that was looking at, how they might make it do something. But I just wanted to show this again, that they've definitely got a stapler that's going to come on there. And, you're going to be able to assign different functions to the different instruments. And that was it, really. So I know I went through that fast, so let me do that again very, very quickly. There's the arm. Imagine 4 of these around the bed. You bring the patient in. You add whatever you need on the side rails of the bed there. You'll then deploy the arms out. You'll press a button on a remote or on the tower, and the arms will come out at 45 degrees and they'll pop up. The staff will come in this pattern. They would then drape the arms all the way down to the base on here. They would then put them into a prep position, which I think is to prep the patient. So they would be able to get to the patient, prep the patient, and get the ports into the surgeon would be down there. Maybe for a different procedure, they would all come to the bottom of the patient. You would place the ports as per suggested. And because you're more or less where the port should be, I think when you put it to the docking position and you go to the procedure position, depending on which procedure, those arms will spread out to the right area. So a little bit like Moon Surgical does today, basically what those arms will get in the right position. And then you'll click the instruments on, you'll click the scope on, put the scope in first, put the instruments in, and then you'll assign them up to the user will then assign them up, and you are ready to do the procedure. And that's it, really. That's what I kind of wanted to go through today. Again, I can't guarantee that this is actually how it's going to be. This is one pattern that I've searched. And the fact that it's come up again, though, recently usually means it's coming to practice. So I'm going to put a little bit of a bet down that's probably the workflow of how it works, or very, very similar. I mean, why wouldn't it? But my big question always was, do they bring the patient in, prepare the patient, then drape the arms, or do they drape the arms and then prep the patient? I think they're going to prep the patient after they drape the arms. And that just shows you basically some of the workflow. And I hope you found that interesting. It was just a little one that I wanted to knock out today, because I've had so many people ask me over the last 6 to 8 months, yeah, but how could a table one work? How could a set of table arms work? Do you click the arms on? Do you? No. Hopefully that shows it, and that's clear. Got any questions? Pop them in the comments. Do follow me on YouTube. Please do follow me on YouTube. Do follow me and go to my blog, howtostartupinmedtech.com. Lots and lots of posts going to be on the blog there if you didn't see this here. And that is it for now. So I will leave it as that, and very welcome to have any comments. But that's what my patent searches showed in recent weeks. Cheers.